So here is a matrix. A matrix is essentially a grid. It has rows and columns. In each location, there is an element. That element is defined by its rows and columns. So the first one, row 1, column 1. This one is row 1, column 2. It'll go all the way to however many you have, A, row 1, column N. Same thing works going down. So this is row 2, column 1. This one is row 2, column 2, and it goes all the way down till we get to, I'm going to use M as the bottom of our rows. This one is column 1, and it goes all the way across to row M, column N. And we always define this as a rows by column matrix. So we would call this matrix A is an M by N matrix. So you could say it's a 5 by 4 or a 2 by 2 or a 3 by 3. So in general, we're represented by capital letters like A or B, not lowercase, usually capital. Every item in the matrix is called an entry or an element. In general, a matrix with M rows and N columns is an M by N matrix. If it has the same number of rows and columns, it's called a square matrix. Two matrices are considered to be equal if the dimensions are the same and all of the corresponding entries are the same. So every single item matches every other item. Okay, so let's look at some examples. Are these equal or not equal? Start by looking at your dimensions. So the first one has 2 rows and 2 columns. So it's a 2 by 2 matrix. The second one is also 2 rows and 2 columns. So they're the same dimensions, so we're off to a good start. Next we have to compare, do all of the entries match? So does 2.5 equal 5 over 2? Yes. 2.5 equals 5 over 2. Does -1 equal -1? Yep, that one's easy. -0.2 equals -1/5? Yep, that one's good. And then last, 3 equals 3. Yes, these are equal. Now, before I even test numbers, look at letter B. This is 1 row by 3 columns. This is 3 rows by 1 column. Are they equal? No. They have different dimensions. Questions? Yeah.
So it's based off of the dimensions and the numbers?
Yep. So then it doesn't matter if the numbers are equal if the dimensions are different.
Wait, and they have to be in the same spot, right?
And they have to be in the same spots. Yes.
So are they equal if the dimensions are the same but the numbers are different?
No. So if they're, let me show you this example. Letter C. If I gave you 1, 2, 5, 7, and I gave you 1, -2, 5, 7, these are not equal because not every entry matches. They're really close, but they are not the same. Okay, first thing, in order to add or subtract, the rule is that the matrices dimensions must be the same. You may not add or subtract dimensions that are different. So looking at these 3 examples before we even get into it, one of them is just not possible. Do you see it? Letter C is not possible. Okay, So adding is actually pretty simple. We add the corresponding entries. So row 1, column 1 plus row 1, column 1. So like this one, row 1, column 1 adds up to equal 5. Row 1, column 2 adds up to equal 3. Row 2, column 1, 9 plus negative 3 is 6. And row 2, column 2, negative 5 plus 5 is 0. Now, here's one more thing. The matrix is inside of very tall square brackets. It means something different if they're just up and down without the little bracket part. So make sure that when you're showing your matrix, you show that they are brackets around this space. And typically, like if you're doing this on notebook paper, you would think about it like, let's see. So notebook paper, here's my lines. I would do this on 2 lines with my big brackets. So if it was a 3x3 matrix, I would have like 3 lines of notebook paper. And then I would have all my entries like this. Make sense? I know some of you write small. As long as it's neat, it's okay. All right, next one. You guys try it. This one is subtraction. So be careful because you're subtracting each of your entries. Give it a try. Couple other things. We don't typically put grid lines. Some students, I don't know why, they like to do that to keep themselves organized. It's not really part of it. You can imagine that they're there, but we typically don't draw in those extra grid lines. It is a good idea to make sure that you have things spaced so it's easy to read, but we wouldn't draw those in. Okay, number 1. And number 2, I'm going to give you guys a minute to discuss these things with your table. Number 1 is matrix addition commutative, meaning can we do A plus B and B plus A and get the same thing? If you're not sure, feel free to test one of the ones up above. And then, does matrix addition follow the associative property, meaning if I had 3 matrices, A, B, and C, if I do A plus B, and then I did plus C, is that the same thing as if I added B plus C first and then A second? And if you want to test it, I'll do this for you. Call this matrix A, call this matrix B, and call this matrix C if you want to test this. Okay? So talk to your teammates. 1 and 2, is matrix addition commutative, yes or no? If no, explain why. And does addition follow associative property? 60 seconds, go. All right, are we ready? How many people think 1 matrix addition is commutative is true? You are correct. Order of addition doesn't matter. What about subtraction? Subtraction is not commutative. Yes, the order matters. Yes, you correct. So addition is commutative. Let's put an asterisk. Not subtraction. Okay? And then does matrix addition follow the associative property?
Yes.
No.
It does.
No way.
It does. Because you're adding, it doesn't matter which order you add them, they all add up, they all get added in the same spot. So it does follow the associative property. Yes. Okay. So, first kind of multiplication. Scalar multiplication is like distribution. It's not distribution because distribution is a different thing, but it's like having a single number, which we call our scalar, and we multiply it times all the stuff inside the matrix. So we multiply each item. We'd have KA, KB, KC, and KD. So we can multiply by a single value. And combining what we know about adding and subtracting, we can do some other calculations too. So we are going to use A, B, and C, and we are going to do these three calculations. First one, 4 times matrix A. So 4 times matrix A, 315, negative 206. Oh, by the way, I don't know if you've noticed, when you read out the entries in a matrix, you read just like a book, left to right. So 315, negative 206. I multiply each of these times 4. 12, 4, 20, negative 8, 0, 24. Questions? All right, let's try 1/3 C. So 1/3 is multiplying by a fraction. It's the same as dividing by 3 though. So when we look at this, we're doing 1/3 of 90, negative 36. 1/3 of 9 is 3, 1/3 of 0 is 0, 1/3 of negative 3 is negative 1, and 1/3 of 6 is 2. All right, challenge question. Letter C. I'm going to let you try that one with your teammates. See how you do. Then we're going to talk about calculators. How'd I do? Did I make any silly mistakes?
Nope.
Cool.
Oh wait, 24 is negative 4.
It's 18 minus a negative 6, so
Oh.
yeah?
I'm
You did backwards?
Yeah.
Okay, get your graph and calculator. Oh boy. We'll see how this one does. I wonder if... So on your graphing calculator, we're gonna try to use this one. I have a different one that I think I like better, but we'll try with this today. Underneath the math button, do you see the matrix? So you go second, matrix, and it's gonna pop up A, B, C, D, E. Are you with me? Underneath the math button on the left-hand side, there's a little tiny matrix. You go second, and then it's actually next to the -1 button. That'll bring up the matrix menu. These are the names of the matrices that you have available to use. If you go to the math menu, these are the things we can do with it. We haven't learned about any of these yet, but we'll get to it. If you go arrow one more over, this is the edit menu. This is where I can edit matrix A. So we're going to edit A, B, and C and put in the ones that are on our worksheet to make sure we know how to do some matrix math on the calculator. So A, hit enter. My matrix is currently a 1x1. Yours might not be. You want to adjust it so it matches what you have. Our matrix A is 2 rows by 3 columns. And when you type in 2 by 3, you'll notice that it adjusts to look like that. Then we type in from left to right our values. 3, enter. 1, enter 5. -2, enter. 0, enter 6. And now, if I exit out of this and go back to my home screen, when I go to use matrix A, it looks like the matrix I just typed in. Ta-da! Do we see it? Okay. Now I'm going to type in matrix B. So matrix, edit, B. This one is also a 2 by 3. This one is 4, 1, 0, 8, 1, -3. And then for our first, I'm going to skip matrix C. I want to show you one other thing. When you go to type this into your calculator, you can actually type in a matrix without storing it. The way that you type in a matrix, so here's matrix C. It was 9, 0, -6, -3, -6. The way that you type in a matrix without storing it is each row gets brackets and you put a comma in between the entries. Then you put a comma after the row and you put brackets around the next row. So when you type this into your calculator, it goes big open bracket, row 1, 9, 0. So I'm going to type it in while we go. If I can find these stupid brackets. Where are you, brackets? There they are. Brackets are over the multiplication. So this is row 1, 9, comma is above the number 7, 0. Close your bracket, comma.
Where's the comma?
It's above the number 7.
No, it's not. Oh.
Is it?
No, it is. I thought you meant like it's like alpha, whatever, above 7. It's
Oh,
just,
no.
like, the key above 7.
It's the actual key above 7.
Wait, it's double
Yeah, I was
brackets on the
thinking
outside?
It's double brackets on the outside because we are putting the parentheses. We've got these brackets around the whole matrix.
Oh, yeah.
And then, hold on. Okay, so here's why this is useful. If all I need to do is one matrix operation and I don't need to save it, I'm not coming back to it, that's almost as fast as editing the matrix in the matrix menu, right? So by typing it in like this, now I can do 1/3 times my matrix from up above, and it will automatically take third of the matrix, just like that. Did you include all the commas?
Yeah.
Did you use minuses or negatives?
Negative.
Oh, my calculator does put the comma.
Like the comma after the second bracket.
It doesn't. Wait, let me try it on the TI-84.
Okay, now it works without the comma.
Without the comma, it works. Okay, so on the TI-84, no comma. Sorry. Okay, so let's verify letter C that we've done it correctly using the ones that we stored. So the way that we use it is we do 3, and then we go and find matrix A, and we choose it by name. Minus 2, and then we do matrix B, and we arrow down and choose it by name. And if we've done it correctly, it'll match exactly what we have. Here's the thing. Doing it on your calculator when they're easy numbers like this, it takes longer to type it in than it would just to multiply and subtract the values, right? So you need to be able to do it by hand, but it's a great tool if you have nasty numbers or if you're like, oh my God, I think I'm making a mistake and I want to check it, right? Okay. So I'm going to stick with the plan. That's it for notes for today.